Hello and welcome to the BranchPattern webinar series. We are about to begin with our webinar, Managing Construction Risks through GC and Enclosure Consultant Collaboration, presented by Stuart Shell, Jimmy Rohr, and special guest Ryan Sawall. I am Nicole Parker and I will be your webinar facilitator and moderator for today. And now for a quick introduction to BranchPattern. For those of you who may not know, we are a building consultancy of engineers and scientists. Our name BranchPattern is inspired by the natural environment and how we use the natural environment to influence our design. Throughout our firm's history, our purpose has been improving life through better built environments. This is our mantra, and we use this message to influence everything that we do. Our beliefs are rooted in nature, which has taught us that true sustainability sits at the intersection of human experience and environmental stewardship. Today, you'll hear from our three presenters, which I would like to introduce now. Ryan Sawall with McCarthy Building Companies. McCarthy Building Companies is the oldest privately held national construction company in the country, with more than 150 years spent collaborating with partners to solve complex building challenges on behalf of its clients. With an unrelenting focus on safety and a comprehensive quality program that spans all phases of every project, McCarthy utilizes industry-leading design phase and construction techniques combined with value-add technology to maximize outcomes. Since 2005, Ryan has traveled throughout the United States as a professional mechanical engineer with McCarthy Building Companies. Large complex buildings, including buildings in Ohio, Nebraska, Wisconsin, and Louisiana. Ryan currently lives in Omaha and is Vice President and Business Unit Leader for McCarthy's Nebraska and Kansas City offices. A few fun facts about Ryan. He's an avid drummer and fisherman when time allows. He has been married almost 20 years, and the eldest of his two daughters just graduated 8th grade and is starting high school this fall. Next, we have Stuart Shell. Stuart is a senior associate with BranchPattern. As an architect and building scientist, his focus on performance-based approaches to enclosure design and renovation. Stuart is also an expert in indoor environmental quality and occupant comfort. A fun fact about Stuart, he put building science principles into practice when he built a little free library for his front yard. And next we have Jimmy Rohr. Jimmy is a registered architect in Nebraska and Colorado. His passion for building science and technical details has led him to become a building enclosure consultant. Jimmy joined the BranchPattern team in 2019, where he brings extensive experience specializing in high-performance envelope design. His technical design background allows him to integrate with project teams in various stages of development to optimize designs for performance. A few fun facts about Jimmy. Jimmy's love for travel has taken him and his wife to over 30 countries. He's an avid snowboarder celebrating over 20 seasons riding and previously served as president of the Nebraska Ski and Snowboarding Club. And yes, that club does exist in Nebraska. He has an almost 3-year-old son and one more due any day now. And he is currently hoping that his wife does not go into labor during our presentation. Now let's get started.
Thank you, Nicole. We're so glad that you're here with us today. We're grateful, honestly, in these uncertain times to be able to remain somewhat productive and effective as we work from home. And we thought this webinar series would be a way of supporting you where you're at. And I want to just offer that support also to your clients if you guys have things that are challenging, as we look at especially how buildings operate to keep us healthy in these times. Please reach out to us. We're trying to find ways to strengthen the resilience of our buildings all the time. The enclosures is a key piece of that, so we're happy to be talking with you about that today. This is an AIA continuing education opportunity. We're a provider. Our goal today is to really talk about the ways that we can reduce the risk of problems on buildings by looking at enclosures, and especially looking at what high performance teams do in order to provide that type of assurance. Specifically, what we'll end up with today is a better idea of understanding how to avoid moisture issues with buildings. Moisture is associated with mold growth, so there's impacts for indoor air quality also there. We also want to look at specifically the design side aspects of quality assurance for the enclosure, as well as the construction side aspects. And we're excited to have Ryan's expertise and experience from the field to draw on, especially. So that's a treat to us. Enclosure consultants, we learn everything we know from the field and how things perform. As an evidence-based practice, that's where we go. So we hope you'll take advantage of Ryan's presence here also, and feel free to ask questions along the way to get access to that. As we get started, let's launch our first poll. Nicole, who do we have in the room? If you can give us a response to this, it'll be up for a second, but this will help us frame a little bit of the discussion so that we're talking in ways that are more helpful to you, and also give you a little insight about who else may be asking questions along the way. So it looks like those answers came in pretty quick, and we have, you should be seeing the results now. Almost half of the call is the architect community. So we got the designers, we do have some contractors, so some peers for Ryan to speak to on the phone also. So that's good to see. Smaller contingent related to the owners. So that's good. The owner ultimately has the most power over the quality of the enclosure by choosing, you know, the contractor you want to work with, the design team you want to work with are the first choices, and then obviously which additional quality assurance services you may want to employ along the way. So enclosure consultants may enter into a construction project in a few different ways. And we're talking specifically about enclosure consultants that are engaged on the contractor's team in this presentation, which is not the most, maybe the most common way, but we're seeing it increasingly common. And the other dimension is enclosure consultants might be working on the designer's team, you know, hired by the architect to support them in developing their designs and reducing the risk that the architect experiences on a project. Oftentimes, enclosure consultants work directly for owners too, and that we normally call enclosure commissioning. They're operating more as a third party with some insight into both the designer's work and the contractor's work. But again, specifically, we're talking about how enclosure consultants help contractors deliver their scope, as we're seeing people like McCarthy wanting to bring this in at a baseline level of service to limit the risks that they experience on projects. So a couple caveats, this is not a design service. So enclosure consultants are necessarily respectful of the responsibility that the professionals of record have on the project, and they ultimately take responsibility for the design, and so we're deferential when we're serving as an enclosure consultant. My first career was as an architect, so I appreciate that especially. We also don't help, you know, deliver the project. So before I pass it off, I want to sort of describe how we're going to structure this. The first part we'll be talking about some of the design elements to make sure as you mobilize on the site to start building, you've got a good plan and that there's clarity around what the design intent is. Then we'll talk more in details about how a quality assurance program within the contractor's house can really ensure that we're delivering excellent results. I want to invite you again to ask questions along the way. We'll aggregate those at the end, but you don't need to wait until the end to ask the question. So if something pops into your head, type it in right now. We'll also be answering live as Nicole described. So with that, I want to pass it to Jimmy to describe what the design phase services might look like.
Thanks, Stuart. I'd like to take the time to give a general overview of the enclosure consulting process during the design phase. As Stuart mentioned, enclosure consulting is a form of risk management. And the review process, if started early in the design phase, is one of the first opportunities for the design team, owner, contractor, and consultants to collaborate to refine and optimize the construction documents. As enclosure consultants, some of us being architects ourselves, we understand and respect the fact that the architect and design team have already invested a ton of time and effort in generating the details that we're reviewing. So we primarily act as a fresh set of eyes for the project team. We're not there to push certain products or building methods. And in fact, the particular instance shown here we were able to work together with McCarthy and the architect to come to a solution for air sealing and insulating the parapet to meet the project needs. And of course, every project we have the privilege of reviewing presents itself with unique details and a variety in varying design and budgetary constraints. The expected lifespan, building typology, and the climate zone all play a role in the advice enclosure consultants provide. It's fair to assume that a single family residence would have drastically different constraints than, say, a hospital. And furthermore, if you took the same hospital, built one in Omaha and another in Houston, it's likely that there would be unique details tailored to the respective climate zones. So when collaborating with the contractor and design team, our focus is to review and advise on the performance and the products detailed and specified. And the truth is, there's a variety of great products on the market at all price ranges to meet the goals of the project. The primary focus then is to understand how all these products interface with one another. On even the smallest project, there are hundreds of transitions which can determine the success of the project. Working directly with McCarthy, we have been able to assist them in identifying details with potential high risk and even identifying certain details that may have been omitted. So what exactly are enclosure consultants evaluating at these transitions? The short answer is the continuity of the control layers. So before we go any further, I'd like to stop and take a quick poll of the audience. So this is intended to be, in your opinion, so of the four main control layers, which one layer is the most critical to get correct to minimize risk? The water control layer, air control layer, vapor, or thermal? So we'll wait just a second for the results. Perfect. Thanks everyone for participating in the poll.
These architects know what's up.
So while all of these have inherent risk factors, the one that causes the most callbacks in litigation is water. So if you don't get the water control layer right, you open yourself to the most potential risk. So that said, with new products being developed at a rapid pace, many of these layers are being combined into one simplified assembly. Excuse me. So back to the question of what exactly are we evaluating? Starting from below the slab, up to the walls and the roof assemblies, and even the fenestration systems, each aspect of the building enclosure is evaluated for material and assembly performance and continuity of the control layers. As I mentioned, many materials can act as several different control layers. They could be the water control layer, air, and vapor all wrapped up into one, in all four of them in certain products. So the key is ensuring that the water control layer of the wall is connected to the water control layer of the windows, and the air control layer of the wall is connected to the air control layer of the parapet and the roof, and so on. One simple way to do this is to perform the pin test, starting at the slab or the roof. Can you connect all the components of the assembly to one another's control layers without picking up your pin? And this is sometimes easier said than done, and becomes even more difficult at corner conditions and where not just in one area, but three different planes come into play. However, these are the areas that are most vulnerable. So coming back to the parapet detail I showed earlier, this is the perfect example of the complexities of the detail process and how we can collaborate with the design team and the contractor to come to resolve certain issues. So this showed multiple options that we ended up landing on one that we all agreed on. So once we've had the chance to review the construction document, the enclosure consultants will typically generate an issues log identifying the areas for potential improvement. The comments are assigned to their respective disciplines or generically to an enclosure system if multiple disciplines are involved. From there, the design team and or the contractor will have the opportunity to respond and discuss the comments together. And again, that's going back to that example where we were able to work as a team to finalize that detail. So, so once construction is getting ready to begin and the contractor is gathering submittals from their subs, we're able to assist in confirming that they align with the contract documents, essentially just back checking that the submittal is matching the construction documents. And at this point, the installers are involved, so we're able to conduct pre-construction meetings and stuff like that. So with that, I'd like to turn it back to Stuart.
Thanks, Jimmy.
Yeah.
The construction phase is when everything starts to mobilize, and enclosure, is involved from the very beginning related to waterproofing of the subgrade construction. And so observation is a key part of that. We're going to skip observation because it's very similar. There's mostly the folks that understand the design process on the call. So you understand what that looks like. It's really, as an enclosure consultant, just a second set of eyes with what the design team will be checking for already during their observation visits and the internal quality assurance protocols that the contractor team has over their subs work as well. So we want to talk about testing, which is, especially regionally in the Midwest, a little fresher for a lot of our projects. And the first test that we want to touch on is what's called the spray nozzle test. And it's because it's simple and pretty straightforward. We see it get a lot of use. Ryan, do you want to give us some examples of how this has come into play for your team?
Yeah, the AMA 5012 test is actually one of our absolute favorite tests. It's simple enough and easy enough to conduct that any one of our field operations folks can do this test, and so we do it quite a bit. And this generally finds most of the problems and issues. So this test only takes about 5 minutes to do. You have to have a specific calibrated nozzle, and it's a nozzle that every one of our teams has in their toolkit, and it's become very effective tool for us to use.
Another test that's one notch up is bundled under AMA 503, and it's actually two tests. So this is a lot of acronyms, but ASTM E783 and 1105. And the simple way to think I guess, distinguishing about this is we actually build a pressure chamber. That's what you see in the image here, that we can depressurize so that we're actively drawing air and water through the assembly that we're testing. This is simulating wind-driven rain and air leakage. You do the air leakage test first, and then you turn on the spray rack and do the spray test. That's because the water will mess up your results for the air leakage. It needs to be a dry assembly for that. How have you guys used this test at McCarthy?
Yeah, so this is another test that we use on almost every project, and we use this test whether it's specified or not, but we do see this commonly specified in the front end requirements that our architects and owners require us to do, but we find value in it regardless. This is a little bit more complicated, like you said, Stuart, and our team usually relies on a building enclosure consultant or a testing agency to help us implement this test and actually put it into practice. We also lean on our building enclosure consultant, like your team, Stuart, to help document what's going on officially, and then also help us find the issues and fix them if there are problems. We've found that this testing, we generally do as a sampling, so maybe 10 or 20% of the project. And if we have a failure, we'll continue to ramp that up. If we fail once, we'll test 2 more times. If we fail again, we'll test, you know, so on and so forth until we have a high level of confidence that we have a quality product.
So this is an example of a higher ed project where we identified as consultants on the team an area of high risk, just because we often see leaks with clerestory windows. I don't know what exactly it is, the combination of higher exposure plus maybe more complicated detailing to observe during the construction process or whatever. So this is a location we wanted to test. You see from the outside the spray rack setup, from the inside the pressure chamber that's constructed. And in this case, we actually did find that there was an issue with the transition, that we weren't getting the correct bonding of the sealant joint to the air barrier system. And this was great to be able to do before the siding was installed on these exterior clerestory locations. So timing can be a factor when testing is accomplished. And that's another thing that's nice about having the contractor coordinating the testing within their house, is that they can make sure that the test is deployed at the time for optimal benefit for their construction, and also in time to catch issues before, you know, work's progressed and it becomes more challenging. You can also use this test for non-windows. It's designed around the concept of windows, but often these protocols are adapted for testing other considerations. Anytime you have something that your team hasn't done before, whether it's a novel design detailing that maybe hasn't been proven in the field, or if it's something that the contractor hasn't, or the sub hasn't installed before. Let's keep going, but again, I see there's a couple questions coming in. Those are great. We will get to those in a second. And a couple I can maybe answer along the way. For example, one was, do you agree that if we are doing 783, the air leakage test, it's easier just to do 1105 for the spray rack versus setting up for the spray nozzle test, 501.2? I'd say that's true. Yeah, it's really, in every case I've been experienced with, 783 and 1105 are done as a combined test because you've already gone to the expense of setting up for the air leakage. Ryan, I'm seeing a head nod. Is that kind of been your experience too?
Completely agree. Yep, absolutely.
Right. So let's keep going to cooler tests. This is a dynamic spray test, and it's a different way of creating the same type of pressure challenge to test an assembly type. Ryan, give us an idea what's going on here.
Yeah, so this test consists of a big fan that's, you know, generally on a forklift type of an apparatus, and then it has a spray rack mounted in the front of it. And so this is trying to simulate almost real life that windstorm with a driving rain, an experience that you could see in a real storm. And so this test is good for when it's really hard on the inside to build that chamber situation and create that simulated test from the previous one we talked about. It's also good if you have a lot of testing that you need to do, or access is a challenge. This can be a benefit. The negatives to this test are it's very costly for the equipment and to mobilize it, but you can do a lot of testing in shorter time frame. The setup time is less. So
great. Yeah, we see this especially on larger scale projects where it really is a benefit to have that counterbalances the additional expense of the getting the apparatus to the site. So another overall test that we can provide and really makes sense for every project is thermography. That's because it's essentially like taking pictures. You just need the right conditions for the images, the thermal images, to be useful. So this requires enough temperature difference. 20 degrees is great if you can get that. It also is more beneficial if you're taking pictures from the exterior. If you can get the building under positive pressure, that'll accentuate the air leaks that may be in the enclosure. So you really end up seeing two different types of losses. You see the air leaks in the form of washing that may be occurring. You can see the heat signature of air leaking out of enclosure systems. You also see thermal bridges. So if those aren't air leaks, that's just where there's not insulation you know, providing continuity around the enclosure. I know you guys have become experts at this. How does it work at McCarthy?
Yeah, so for about the last 10 years, we've had a full-time certified infrared thermographer on our team, and so we've been capturing data for a long time. And we scan every building at completion, and then again at the warranty check of the 11-month walkthrough, and it's given us a lot of data, and we've found some things that are interesting that you might not ever find that you can go in and fix before they ever become a problem. We've gotten more efficient with technology, and we now have a drone that has an infrared camera on it, so we can take pictures of the facade and the roof much more efficiently and safely.
Awesome. So one final test that we'll touch on is related to whole building air leakage testing. And this is something that we're seeing more common, even getting incorporated into the code language for the 2018 Energy Code update. This puts the whole building under pressure using fan pressurization. You can use blower doors like you see in the image, or you can use the installed equipment, especially if your building has like a mechanical system with economizer function or free cooling. And you get one number in air leakage generally per square foot that estimates the total air leakage through all of the assembly components. So a common target is like 0.25 CFM per square foot of air leakage at a test pressure of 75 pascals, which is about 0.3 inches of water, which is not super high pressure, but there are some challenges with this test in terms of getting useful, actionable outcomes. Ryan, what's been your experience there?
Yeah, so this is, we're a huge advocate for testing and the value that brings to the building. This one is not that. This is actually our least favorite test. And, anybody who will listen to me talk about this test, I'll share with them. I don't think this brings a ton of value. It's not a cheap test to conduct. And at the end of the day, it doesn't tell you where your issues are. It doesn't help you pinpoint those problems. The building is done at this point, and there's not a lot you can do to make corrections unless you're going in and doing a lot of expensive investigation and tearing stuff apart. This test doesn't even say that you'll have problems. You could find out, digging into this test, you could find out that this is in fact what the design led to and everything is working appropriately, and it's a number higher than you expected.
Good points. Yeah. I see a couple questions that are related here, and so maybe I'll just roll these in instead of waiting until the end. One question is thermography a cost to the owner, and generally I'd say it depends. In the case that you have a contractor on the team, like the McCarthy, it might be part of their quality assurance procedure that's just included with their presence on the job. When you get McCarthy, you get that. And increasingly, that's been our experience too. As we are involved on projects as a commissioning agent, we generally will incorporate thermography into our base service. We feel that that's a kind of minimum bar, but it is a cost. I mean, it does take time and expertise to do it. So I'd say that's a not exactly easy question to answer. We're seeing it more a base service though. I don't know, do either of you want to add any detail to that?
That's generally, how we approach it, Stuart. It's a service that just comes with us. We do it on every project. We don't really charge for it, but there is a cost associated with it. So. Great.
One question that came in directed to you, Ryan, is: do you find it more beneficial to do the water test on a separate exterior mock-up or on the building itself? And I think they're probably talking about a spray test like that AMA 501.2.
I would say both, if I understand the question correctly. I think there's value. The more testing we can do early and set the quality control, quality assurance processes, the better off you are. if you're doing 100 windows, you want to get the first one right, find out all the issues and problems, and fix that along as you go. And so we try to build that into our schedules and processes, and we found it to be more successful.
If I can add to that, one of the projects that we're collaborating together with, that's exactly what we're doing. We started with the mock-up. It makes sense to start with the mock-up because that's not a part of the constructed building itself. You can find out what went wrong, fix it, and so there's actually minimal issues on the actual constructed building. And then we tested it again on the building just to confirm that what we did on the first one is performing correct.
Great. Well, let's keep going. I want to give a couple more examples of how enclosure consultants may be involved in a project. This first one is actually an example of a client that McCarthy had with it, that they had a problem on one of their projects that led to further investigation.
Yeah, since we've been putting so much focus on building enclosure, we get these calls all the time. Older buildings, different situations where, hey, we have this problem, can you come look at it and see what's going on? And so something like this, we actually found a condensation problem, and we said, hey, we want to get an expert involved. And so Stuart, we reached out to your team, so maybe you can talk a little bit about what we found.
For sure. So at this critical location, we were paying a lot of attention to where exactly the moisture was coming from. We don't take anything for granted, especially in an existing building. We did find really low frame temperatures, which supported the detailing that we found. So we used multiple methods to try and triangulate on the potential cause or causes of moisture problems. And yeah, based on the humidity that we logged in the space, it was obvious that we were just condensing moisture out of the air on the frame system. Pretty straightforward in terms of the failure. Why this hadn't been an issue earlier, this was a building that had been in operation for a while. Those were some of the questions that we were interested in discovering. And I think we resolved that it was probably changes in how the space is used actually, and changing the set points for humidity in the building as they've continued to get closer to that 40 or 50% humidity optimum for operatories. What do you do? We can help support the design team in terms of possible strategies that might be investigated as appropriate, and help also sort through what would be a reasonable strategy for remediation versus what is likely to maybe compound the issue or be a sort of half solution that isn't totally satisfactory. So that was an example of the service we provided. We also may get more involved in analysis if you have special conditions that are not typical. In this case, we were working on a building that's on top of a mountain. And so the mountain's always frozen. It's at elevation, it's at 14,000 feet. So normally that's not the condition with footing. Normally footings are below the frost line. This is kind of the opposite. So we're constantly losing heat to the mountain. How does that work? We use a two-dimensional finite element analysis, software called THERM, to estimate what the amount of heat loss would be into the footing and also predict what the surface temperatures would be. So it gives us those two sort of valuable design insights that inform what the loads will be for the building, but also is there a condensation risk that we need to attend to based on the detailing. And what you see here is a comparison between two options that were being evaluated by the design team. Another unique condition you might run into is retrofitting historic buildings. I see actually a question, does air barrier testing have more value on existing renovation projects? And I'd say yes. This is a point where I'd say it really is nice to know where you're starting from. And the whole building air leakage testing, that fan pressurization we were talking about earlier, can actually have a fair amount of value in giving you a starting point for air leakage and maybe even setting a target that the design team can consider as they look at ways of addressing the renovation. In this case, we had a lot of moisture getting into the brick wall. We aren't sure what's going on here. There appears to be some efflorescence on the inside. So we constructed the thermal model. The image you see on the bottom here is actually a section of the wall. So the outside's on the left and the inside's on the right. And this was a solid mass wall barrier system, how most historic buildings are. This is how we modeled the existing performance, which shows pretty high loading of moisture. The green as shown there is the amount of moisture in the vapor pores within the wall, and the blue is the liquid moisture within the wall. By providing a water repellent treatment on the outside of the wall, it actually had a dramatic impact of reducing the moisture load within the wall. So we found that this was, we evaluated a few different options, and we found that this was the most impactful. We also use this type of hydrothermal analysis to simulate what the indoor surface temperatures will be also. And the real effect of the insulating value of the wall, when you consider the fact that insulation doesn't work as well as the moisture content changes. So it allowed us to evaluate things like adding thermoplaster, a product commonly used in Europe, and gaining some traction here as a retrofit strategy for this historic building. All right, so that's a lot. Just one more reminder to ask your questions as we get into this last part of the section of where we really want to get an idea of what a contractor can incorporate in their house to really deliver this type of quality assurance on projects.
So why focus on the building enclosure? Well, the risk is serious. The risk is real. Those pictures and headlines you see over to the right hand of the slide, they are not McCarthy headlines. They're not McCarthy projects, but those are headlines that you'll find easily if you pick up the paper, do an internet search. They're happening all the time, and it's a big deal. Our industry has increasingly had skilled labor shortage issues, and so just more and more there's a heightened awareness of having to make sure things are done right so that our clients and owners don't have issues in their buildings. Over 15 years ago, we had some painful experiences where we had to hire forensic experts and consultants and lawyers and attempting to defend our position that we built exactly what was on the documents. And we put an enormous amount of time and effort into defending that position. And we said, there's got to be a better way. There has got to be a better solution. And so that's really, we retooled our quality program, and we have had, minimal issues since then. And we've really found that this is an opportunity for the designer and the contractor to come together to find a better path to develop and deliver better buildings. And so our building enclosure program, it incorporates a couple really key elements: design verification. We'll talk a little bit more about these later, but mock-ups, which we touched on already, and quality control, quality assurance, and owner training. If you go to the next slide, Stuart. Verification of design is kind of the start of the building program, and this is critical. And since there's a lot of architects on the presentation today, I think it's important. Our intent of doing this process and going about this is really to develop a better product. And so we want to make sure that we can build what is designed and that we don't have any issues. This is not a finger pointing session. This is trying to find the best solutions to provide a product that we can all be happy with. Jimmy, you've been a part of this design review and understand what's important for us to look at. You want to just talk about some of the things we've done together?
Sure. So actually what's on the slide is an example of something that we've done, work together on a surgery addition. So obviously the details of the control layers are critical. So this is our analysis and what we turned over to McCarthy for their input into how we believe that some of these details could be improved upon. So again, those numbers just indicate those control layers and how we can address some of the minor details in certain instances. So
often we find that all of the information that our design partners and professionals put together is all there, but to be able to effectively communicate that to the installer who's putting that work in place and how those details come together in the corners and intersections, That's critical, and a lot of times our building enclosure consultant helps us work through those specifics and details. Excuse me. You go to the next slide, Stuart. So mock-ups. This is an important part of our program. Very important. So our virtual mock-up is really where we start. So we like to start to do this virtually and understand the sequencing, understand part of our QA/QC processes. A lot of times we find a lot of the issues in the virtual mock-up, but it's hard to actually recognize them until you do the physical mock-up. The physical mock-up is one that transitions to actually making the installers, and we make it a point to have the actual installer who's going to be on the project install the mock-up, who's going to be doing it in real life, so that he understands the process and we get it right the second time as we repeat it. The biggest thing I've learned from doing physical mock-ups is that you talk through these details and issues, and you say this is probably going to work, or this probably won't be a problem. And what I found throughout my career in doing this a ton of times is that probably leaks. And so we've taken the mock-up from, you know, just doing this and working out those details physically to testing them to validate that what we said is going to actually work. And Jimmy, I think you were going to talk about some of the inspections that we do in the field.
Yeah, so this is an example of one of the areas. So this was just an inspection that we did on one of the mock-ups, and just observing some of the details. So it's like you can detail it until you're blue in the face, but if the installers don't understand the detail properly, or whatever it might be, this is our opportunity to catch that. And so this was the opportunity to catch thermal bridging and anything that might affect the performance of the building.
If I had a nickel for every time a mason or somebody told me I've been doing this for 20 years and this is exactly the way to do it, you know, and working through and understanding what the manufacturer rep actually says it's supposed to be installed, I'd be a rich man. Anyway, so moving on, the quality program that we have, you know, testing is probably the most important thing, and you can see a McCarthy gentleman there. They're doing the AMA 501(2). That's what it looks like. You stand about a foot away for a 5-minute period and really testing. We like to do this test in corners, in areas where there's a high likelihood of a failure going to happen. So we maximize the amount of testing we do. We want to find those issues, like I said earlier, and then we want to bring the team in, both holding the installer accountable, our team, and then technical reps, the product manufacturers, and then building enclosure consultants. We like to bring those guys out to look at this from an expert set of eyes. We actually use the building enclosure consultants to help train our people too. These guys, Jimmy and Stuart, they have a trained eye for finding problems. They've been involved in forensic science and seeing things when it goes wrong. That's what they do every day. Our team hopefully doesn't see a lot of issues. We see a lot of solutions, and so we use this as an opportunity to train our team as well. Here you can see a couple of the tests that we've come across over the time. So we do these tests to check our corners, make sure as we're putting things together that it works. On the left, you see a roof drain, a common area of issue. We plug them, fill them with water, make sure they don't leak.
Ryan, I lost your audio.
Oh, you did?
Is that just me?
I can hear.
Amy,
oh, you are?
Do you have audio? Oh, okay. Sorry.
Yep.
I apologize. Must be on my phone.
And then the picture to the right is really an NDAM test, and this is another area where, if done incorrectly, can provide problems. Owner training is also another thing. You know, we want to make sure when we turn this building over to the owner that they understand how to maintain it so it lasts for a long time. A lot of the materials we use aren't built to last forever, and they have to be replaced and repaired and maintained. You can go to the next slide, Stuart. So this is a project that I had the benefit of being involved in. It's a VA New Orleans Medical Center. It's the replacement hospital for Hurricane Katrina. It's a little bit over $1 billion project. It was 2.5 million square feet, consisted of 9 different buildings. 2 of them were historic renovations and had some of the challenges you would imagine associated with those changes or challenges. But we did a mock-up on this building to try to identify and fix some of the issues. The enclosure package alone was over $100 million worth of work. And being in New Orleans, this had blast requirements for the federal government and then also hurricane requirements. So there's some challenges there as well. But this mock-up cost us $500,000 to build and test and remove. But we found a ton of value. We found a lot of issues. We were able to correct those issues. And we went through an exercise to calculate what was the value of that exercise in doing this mock-up. And so while it cost $500,000, it benefited the project and the federal government $5 million to go through this exercise. And this exercise was over the span of about 4 to 5 months to get through all this. You have to have the proper planning and timing to be able to accomplish that.
So to bring a summary, we want to emphasize that enclosure consultants can help enforce quality assurance on a project, especially when incorporated on the construction side with a team that is most, close to the actual quality of the work that's being installed. That experience of people that just spend their time looking at enclosures can be a benefit to all parties in the contract as well. It's a great way of validating that the project that you're handing over to the building owner is ready to go, with a much reduced likelihood of getting those callbacks that happen from problems with leaks. So with that, I'll turn it back over to Nicole.
We would like to facilitate a dialogue about this topic. If you're interested in participating in a follow-up discussion where we can see your video and hear from you, we would love to get that scheduled at your convenience. I would also like to bring your attention to our next webinar, Living Building Challenge and the Pikes Peak Summit Complex, will be presented on June 3rd. And it was an example that Stuart touched on during our webinar today. Again, we will be sending out the survey. This is how we will collect your information for AIA credits and for a certificate of completion. You may also indicate if you would like to receive a copy of the slides. So please take a moment to complete the survey with that information. And now it's time for a Q&A. And Ryan, I'd like to kick it off. There's actually quite a few questions for you, but I would like to kick it off with, do enclosure consultants create conflict within the project team?
So, it's interesting. We've been doing this for a long time, and every project that we have, we try to have some process of this or some type of it. And so the architects that we've worked with a long time and the owners that we've worked with a long time, this is just old hat and it works and it's easy. But those new experiences, it can be a little confrontational up front, and so you have to set the stage. It's so important to say we're not out trying to say we're providing value by attacking this design. We're out saying we want to figure out how to build this the best way we possibly can and make sure that none of us have to deal with this after we're done building it, because that's where people start losing money. Reputation gets damaged, and it's just not pleasant for anybody.
Great. Here's another one for you, Ryan. Do you turn over the thermal imaging reports to the owner, or are they just used for internal purposes? And what are the typical issues that you're finding within these reports?
Yeah, absolutely. We turn over those reports, and even if we do intermediate evaluations, we give those reports to the client it's good for them to have for their records, just like it is for us. We want to make sure that if we do have an issue down the road, that they know we weren't manipulating that data. They had it right when we had it. The issues that we have found, most of the time they're in those transition areas. We found where the expansion joint, usually they have 2 layers and there's supposed to be insulation in between them. We've found where something happened, and when they put that second layer on and you can't visually see it, the insulation was taken out or removed. We found issues like that on the inside of the building. You know, we found where breakers were running hot or pumps weren't working appropriately. A lot of stuff in corners, in roofs. Oftentimes, you know, and this is something that's unavoidable, you will have somebody steps on a screw on the roof and you don't see it. You know, it's a pin type hole, and it's not something that you would catch in normal, unless the person who did it, you know, brings it up and says, hey, I have an issue. Sometimes you find that after the fact in thermal imaging, and you may not have even had a leak in the building, but it's there. It's just going to take another, you know, couple big rains to come through. And so you can fix those, remove the wet insulation, and move on with little damage.
I think we have some more questions lined up for you, Ryan, but I want to jump in with one that is about how enclosure consulting or commissioning gets incorporated into contracts from the owner's perspective. And I think the question specifically is, oftentimes AE services are more of a commodity. It's challenging to add any scope, you know, if you're being competitive in that sense. And I hope I'm paraphrasing this the right way, but is it easier to bury some of the services, so to speak, in the contractor's scope than to try and get the owner to pay for it on the front side as part of the design contract? Since, you know, the number for the construction contract looks bigger than the number for the design, you know, the soft costs on a project. I'm interested to hear what you guys think. I'll give you my perception is that I am seeing a trend towards more testing incorporated within the contractor's scope. I do think there's probably a role for a third-party commissioning agent that serves almost like the other commissioning agents on a project. So we're seeing the MEP systems commissioning agent get sort of starting to roll up some of that enclosure commissioning service, which is more of a design side or soft cost to the owner. But Ryan, what are you seeing in terms of how owners can manage this cost?
Yeah, so our perspective is not, you know, it's where that falls, if it's on the design team, a third party, or through our team. Our perception is that it is important for the project to do that. And so wherever that cost is picked up or handled, that isn't really important. When we have the enclosure consultants work for us, we don't filter that information. We share that openly amongst the architect and the owner, and we like to keep that open and transparent. We feel like this is a risk mitigation thing that is critical to the nature of our business, and it's something that we feel like we have to do. So that's why we built it into our processes. It's just something we do. We'd prefer to get reimbursed for it, but if we don't, we will do it anyway.
There are a couple of questions in resolve to physical mock-ups. One is, I found that doing a physical mock-up works for the person who works on it, but what about the other installers that have a different process? I get a lot of resistance about doing a mock-up for that reason.
That's an awesome question, and something that's really challenging. You get to, when you're putting a mock-up together, you get the folks who say, okay, we're going to have our expert come out and do this, and so you'll see the best quality, best installation you've ever seen, and then you get to what happens in the field and it's nothing like that, and the guys had no idea what was done or that a mock-up was even done. So that's the first step. It's critical to have the same team install the mock-up that's going to be installing your building. And then secondly, when we do mock-ups well, we use them as a training tool. So we may deconstruct part of it after we test it. And then we say, okay, we're going to do, after we do our safety orientation, anybody on the enclosure team, we're going to talk through everything we learned on the mock-up, go through those steps, and then go make sure. We also, through the mock-up process, we create this QA/QC list, and usually we have our building enclosure consultant help us develop that. So we have the right stopgap measures in place, so we can say, before you go to this step, we have to do an inspection process. You're going to inspect it, and then we're going to come validate it. And that has really been successful.
So it's fair to say that McCarthy does request these physical mock-ups then for your projects. That was another question as well.
Yeah, you know, there are times where we have to do mock-ups like in place. That's not our preference. We like to do them standalone. We'll always do at least a first in place as a mock-up. And if we sometimes schedule and budget, you know, get in the way of some of these things, but we feel like there's a ton of value. You can still do the processes without doing a standalone mock-up, but you can't skip the processes at all. I mean, that's super important.
Yeah, we see a trend towards a lot. We do see a lot of teams incorporating the mock-ups into the actual work, and that can be effective, especially if you're pretty comfortable with the design and they're more traditional. I see that's one of the questions is, do you have challenges with scheduling a mock-up and that, you know, becoming difficult to fit within the ultimate delivery? I don't know. Ryan, do you find that sometimes they get pushed out of projects just because there's not time to get that additional scope in?
Yeah, I'll tell you, Stuart, I'm a big advocate for making sure you build that into the schedule and communicate that appropriately. But yeah, I mean, our clients are more and more trying to build faster and quicker. Speed to market is important. And so you have to work through that. But I had a project personally very early on in my career where we said, hey, we're gonna put one window in and we're gonna test it. And schedule became a problem, and we put an entire wall of windows in and metal panels. And when we were tearing that apart for 3 months and going backwards, that schedule seemed like, boy, we should have took that extra month and went forward so we didn't have to go backwards so far. So it doesn't always work how you would expect, and making the time is going to be better in the long run.
One of the questions that I find really interesting, Ryan, is your example where the mock-up costs $500,000. And the question is, how is that cost worked into the upfront budget?
So with all of these things, you know, it's ideal to plan and budget. So, you know, usually when we're brought on early, and that's where we feel like we can add the most value, we bring our building enclosure consultant on with us early, and then we're talking about that before there's even a schematic design. We're talking about what are the tough systems, tough elements? How can we incorporate those into a mock-up? What is that mock-up going to look like? How does that fit in the schedule? If you're talking about that in schematic design and it's a relatively sizable project, it's easy to build that stuff in. If you're talking about it when you're at CDs, you're going to have a really tough time.
And then have you had any issues with mock-ups and lead time, since timing is so critical for the envelope consulting?
Yeah, that was kind of the question that I tried to ask earlier, and I think we got a good perspective. I'll add that it helps when the design team is able to incorporate the actual details for the mock-up in the documents, instead of trying to settle on what will be included in the mock-up. A lot of times a custom mock-up is actually compressed to incorporate a lot of the complex details into a smaller section. It just makes it more affordable. But that's actually its own design deliverable in some ways. You need to reference which details go in to make that sort of Frankenstein that can get tested.
The biggest thing I've run into with lead times and mock-ups working is, you know, when you're trying to have both a functional mock-up and an aesthetic mock-up, that you want to make sure it looks exactly how you want, and getting the actual colors and stuff to come, that's really hard. I'll tell you, I've had some very hideous looking mock-ups, but we weren't looking for that look and feel of what that was, just that it worked.
I've actually seen multiple where there's one aesthetic and one performance mock-up. So the aesthetic is simply just a tiny segment of brick, or for instance, that the designers are able to look at it for those aspects, and then the performance is looked at for obviously from those perspectives.
One question that I see that came in from Marcel, internal, he wanted me to remind everyone that some owners are increasing humidity levels in buildings as a way of reducing the risk of infectious disease transmission, that the virus isn't as successful when you're at, 40, 50% humidity. That does create a little more risk of condensation in your enclosure though. As you start increasing that dew point temperature, you might be hitting condensation levels on windows and glass and even walls if there's thermal bridges or if you don't have continuous insulation. So there is a benefit to moving more towards more well-insulated construction. And we're seeing passive house pulling the industry a little bit from that perspective in terms of better enclosures that allow us to provide, higher humidity levels for occupant health.
One of the comments that came in that I'd like you guys all to kind of chime in on is she's an owner at a university. The designer has an envelope consultant, the contractor has an envelope consultant, and the owner has an envelope commissioning agent. And I would like your comments on how that all works together, because it seems like there would be some competing entities.
So I can jump in. I will say that I think this is a case where too many cooks in the kitchen is not a problem. And again, that's because there's clear responsibility for the design that lives with the architect, whoever's stamping the drawing, it's their design, right? They're the ones that are making decisions, and they have to incorporate a lot of different design input. Again, we have a deep respect for that role of interpreting all the code requirements with the owner's requirements and the building science. And so if they're getting 2 or 3 design directions from an enclosure consultant, we think that's actually probably better for the ultimate design impact than getting just one direction. And that's been my experience. We often are involved with projects where we're not the only enclosure consultant. And we sometimes have differences of opinion, but as experts, we actually learn from each other too. Just like Ryan was describing, sometimes our knowledge can be helpful for other people on the team to carry forward into their other work. We learn from a community of enclosure consultants too. And so that's kind of my take on that. I don't know, I'm curious if others, if Jimmy or Ryan, do you see that similarly?
I've been on large projects where that has been the case, and I will tell you, I talked a little bit about the dynamic of us bringing in that building enclosure consultant and getting the team to acknowledge and understand that it is critical that we're all out for just the best outcome of the project and check the ego at the door. We're just trying to find the best solution, something that we can build. And the owner can maintain after we're gone. And so that becomes increasingly difficult the more people you have. It's not more consultants, it's just more people and more opinions. If you can focus and center things around that same message, it can be successful, but it is more challenging. There's no doubt about it. More ideas and more opinions and more eyes. Obviously, there's some value to that. But at the end of the day, finding consensus and the best thing for the project is what is important.
I'll add to that real fast. Back to that parapet detail, we came to the table with a variety of options that could work. The result that we ended up with was something that McCarthy, you guys actually suggested, because we're like, hey, we can do it like this, and it's actually going to be a little bit cheaper than this other method. And so, like, if you weren't in the room, we never would have come to that conclusion. And that's the same for if there's multiple building enclosure consultants. If one's not in the room, they might not bring that perspective. And so having everybody's perspective, as long as there's time and everybody's willing to digest that information and do what's best for the project. And sometimes the answer is budgetary, but if you can come up with a solution that's the cheapest and it works, kudos to everyone.
There's a few more questions. How do you feel about BIM mock-ups?
I like that question.
Yeah, I love them. You know, so that's the virtual mock-ups. We find a lot of issues and work through a lot of things effectively in that, but it does not replace the physical mock-up, in my opinion.
I love BIM. I love Revit. Me being an architect in a past life, that is exactly what I did all the time. And so I found so many things through the virtual mock-up, but until the rubber hits the road, it's not quite the same. I think that you can solve a lot of issues by looking at it in 3D, panning and zooming and seeing that. But until it's being built, like you might miss a few things. So it's a great start if you're crunched for time, but it in my opinion, I don't think it replaces the real deal.
Okay, looks like Nicole may have dropped off. I'm just looking at a couple more of the questions here. One is a comment coming in from Connie. We often include enclosure commissioning as part of the lead scope, actually, because there's points on the table for under the enhanced commissioning credit for enclosure commissioning. So that's a good point, and that's actually brought us into some projects. Sometimes I think clients are a little surprised when they are you know, looking for points in lead, and then they actually get you know, the benefits of enclosure consulting that comes along with that. So that's kudos to LEED for continuing to encourage good practices like commissioning and quality assurance on projects.
There's another question for Ryan. Do you have certain individuals that are trained to perform the nozzle test for McCarthy?
We do training. So we have a specific building enclosure coordination program training that we put all of our people through. It shows you how to test. It shows you how to run the test. It tells you how systems work. A lot of the things we talked with Jimmy about. In fact, we bring people like Jimmy in to talk to our team and help train them. And then nothing replaces, you know, I think we've talked about it a bunch, nothing replaces that real world. This is what's going on here. This is what we talked about in training. Do you understand why this is not good? And, you know, that's why we continue to train our people, and we continue to use enclosure consultants to make us as good as we possibly can be.
And how do you communicate with the subs what their bids need to include for mock-up or enclosure testing?
So, yeah, I mean, that's a great question. So we have what we call a front-end document that says this is our quality program. It goes through, you know, anywhere from the roof drain tests to the to that end dam test that you saw earlier. It says how much of that we're going to do, who's responsible to do it, who's responsible to validate it, and what happens if there's a failure. So we explain that in detail as we're going through the bidding process, and we work with them to make sure after they do bid that they understand what that means and that we are in fact going to do it.
And then one final question. I think it relates to your the mock-up, the $500,000 mock-up that you shared. And the question is, was the cost savings and future issues that were prevented, or was it in refining the construction of the building details that resulted in the construction savings?
It was, we projected out issues that we prevented. So, the issues that we found were, you know, manufacturers changed their products. You know, some of the systems completely changed, and these were things that had we gone and built it and then tested it in a typical fashion, we would have been tearing out or putting together costly repairs. So.
Fantastic. Those were all the questions we have that have been answered, and it looks like we'll be finishing on time. So thank you, Ryan, Stuart, and Jimmy, and thank you everyone for attending today. We look forward to seeing you next time.
Stay well, everybody.
Thanks.
Thanks, everyone.